Welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor in Department of Science. Today we are going to talk about digital image processing, which is a course in TYCS syllabus, semester 6. We are going to discuss the topic circular convolution, which is a part of unit 2. So let's start with the circular convolution. First, we will understand what is a circular convolution. Circular convolution is a mathematical operation used in signal processing to represent the interaction between two signals. Here, the very important thing we should know that we are talking about digital image processing. Under this, we are talking about circular convolution. So, all these things are related with the image processing. So, circular convolution is a mathematical operation used in signal processing to represent the interaction between two signals. It is defined as the convolution of two signals in which the convolution is performed in a cyclic manner, resulting in a new signal. So, the convolution is performed in a cyclic manner and you get a new signal. The main difference between circular convolution and linear convolution is that in circular convolution, the input signal wrap around forming a periodic sequence, whereas in linear convolution, the signal extend indefinitely in both directions. So, in linear convolution, the signal is extending in both the direction, and in circular convolution, the signal is wrap around forming a periodic sequence. Now, why circular convolution is important? Circular convolution is important in signal processing because it provides a compact representation of signal and allows for the efficient computation of cyclic and periodic signals. So, it is an effective method as well as it is a compact method. This makes it useful in various applications such as audio processing, image processing, error correction, coding, and wireless communication, where signals often have cyclic or periodic operations. Additionally, circular convolution provides a way to model the interaction between signals that are not necessarily on the same length, which is useful in many real-world situations where signals have different length or duration. So, there are many applications. We are focusing on digital image processing, but other applications are audio processing, image processing, error correction coding, and wireless communication. We will see this thing in detail. Let's start. So, again I am coming to the importance of circular convolution. Circular convolution has significance in various fields because it provides a way to model the interaction between signals that are cyclic or periodic in nature. The following are some examples of circular convolution which are used in different fields. The first one is audio processing. In audio processing, circular convolution is used for tasks such as filtering, signal enhancement, and sound synthesis. For example, circular convolution can be used to apply a filter to an audio signal in a cyclic manner, resulting in a smooth and clear output signal. The second one is image processing. This is our main focus. In image processing, circular convolution is used for tasks such as image smoothing, edge detection, and image restoration. For example, circular convolution can be used to smooth an image by applying a smoothing filter in a cyclic manner, resulting in a smooth output image. So, when we apply a smoothing filter, it's better we should use circular image processing. Error correction coding. In error correction coding, circular convolution is used in communication system and data storage to detect and correct errors in data transmission. For example, circular convolution can be used to apply a cyclic redundancy check (CRC) code to signal, resulting in a signal that can be used to detect error in data transmission. So, when we transmit the data, that time for error detection and correction, circular convolutions can be used. Wireless communication. In wireless communication, circular convolution is used in channel coding and modulation. For example, circular convolution can be used to modulate a signal in a cyclic manner, resulting in a signal that can be transmitted over a wireless channel with reduced error rate. In wireless communication also, to reduce the error rate, we can use the circular convolution. Overall, the importance of a circular convolution in various fields lies in its ability to provide a compact presentation of a signal and its ability to model the interaction between signals in a cyclic or periodic manner, making it useful in various real-world situations where signals have cyclic or periodic properties. This up to now we just try to understand what is a circular convolution, why it is important and where it is used. Now we are going toward the implementation part. So for implementation, the first method which we are going to discuss is the direct method. The direct method of implementing circular convolution involves computing the convolution of two signals in a cyclic manner by treating the signal as periodic sequence. The main step of direct method are as follows. Periodic extension. The first step is to extend the signal to form periodic sequence. This is done by repeating the signal until they have the same length. So the first step, you have to make segments of that signal, and that all should be of same length. So that is periodic extension. Then convolution. The next step to compute the convolution of two periodic sequences. This can be done using the standard convolution formula which is given below. So it is y of n summation m 0 upper caret m minus 1 into 1 of m to n minus m, where x1 n and x2 n are the two periodic sequences and y of n is the output sequence. So here we have two signals x1n and x2n, and we are doing the circular convolution to produce y of n, which is the output signal. Then the third step is the modulo operation. The final step is to apply a modulo operation to the output sequence to ensure that it remains periodic. This is done by taking the output sequence and computing its residue with respect to the length of the sequence, which is given by y of n is equal to y of n mod m, where m is the length of the sequence. So using length of the sequence, you have to find the mod of the actual signal, and that you can use to find output sequence, or to produce the output sequence for the remaining period. Here is one example related with the direct method. Consider two signals. First signal is 1, 2, 3 and the second signal is 4, 5, 6. This is an example. To compute the circular convolution of these signals using the direct method, the following steps you can use. First is periodic sequencing. So the signals are extended to form periodic sequences, resulting in so we can sequence x1n as 1, 2, then 3, 1 and then 2, 3. And the second signal we can divide like 4, 5, then 6, 4 and then 5, 6. Okay. So in the circular way we sequences it in a number of 2, 2, period of 2, 2. Now convolution. Second part is convolution. The normal convolution we have to do. The convolution of that two periodic sequences is computed using the standard convolution formula, resulting in y of n. In the earlier video, I already showed you how we have to do the circular convolution. That we have to apply, and we get a new signal, that is 4, 13, 28, 27 and 20, 11. After that we have to do the modulo operation. The final step is to apply a modulo operation to the output sequence, which is in this case y of n 4, 13, 28, 27, 20 and 11. So sequence of 2 we are using, so that way we calculated and we get this new value. The result of the circular convolution x1n and x2n is 4, 13, 28, 27, 20 and 11. The result represent the cyclic interaction between the two signals and can be used for various signal processing tasks such as filtering, signal enhancement and sound synthesis. Okay. Now we will see one more method of implementation, that is overlap save method. Overlap save method of implementing circular convolution involves dividing the signal into smaller segments, computing the convolution of each segment using the direct method, and then combining the results to form the final output. The main steps of the overlap save method are as follows. First one is segmentation. The steps are almost similar: segmentation, convolution and then modulation. Now the first step is segmentation. The first step is to divide the signal into smaller segments of length L. This is done by dividing each signal into L length blocks and padding each block with 0 to format L length sequences. We will see the example, it will be more clear. Then convolution. The next step is to compute the convolution of each segment using the direct method. This can be done using the standard convolution formula, which is given by y of n summation m is equal to 0 upper caret L minus 1 into that is L minus 1 x1 m and x2 n minus m, where x1 n and x2 n are two segments and y of n is the output sequence. After that, the last step will be overlap and save. The final step is to combine the result of the convolution of each segment to form the final output. This is done by overlapping the output sequence of each segment by L by 2 sample and adding them together to form the final output. So let's see the example of after this overlap and save, we will get the final output. So what is the method? So we have to first do the segmentation. Whatever signals we have to first do the segmentation, then we have to do the convolution, and after doing convolution of each segment, at the end we have to combine all the things together and we will get the final output. Okay, that's all for today. Thank you.